So it was a pure mathematical theory, representation theory, and proposed by Newman and used by the physicists to show that the quantum mechanics works well. So I will spend the time to explain you the representation theory. So about the operators. So operators, Hilbert space, and orthogonormalization. Orthogonormalization. This subject is, and sometimes they call it orthonormal. Yes. Orthogonalization. So this subject is very much dependent to the differential equations. And one of the modern theory about differential equation is the Sturm-Liouville theorem. So I will explain you about the Sturm-Liouville theory. So Sturm-Liouville theory is the theory about the solution of differential equation, even you don't know the form of the solution. You have just the equation and you know the condition which the solution should be satisfied. So, and you develop the theory to expect that which kind of the solution you will get finally. You don't know the form of the solution, just you expect the property of the solution using the Sturm-Liouville theory. So the representation theory will be, and the quantum mechanics heavily uses the matrix and determinant. So but the problem is that the matrix here, you know the normal matrix, you know from elementary mathematics. In quantum mechanics, there is a difference that normally the matrix are infinite line and infinite row and infinite column. So you need to understand that how to handle the matrix with the large size actually. There are another mathematics here we needed to know, and again is the solution for the Helmholtz equation. We needed to know that also how to solve this easy equation, just Schrödinger equation. So this is actually a type of the Sturm-Liouville equation. So if you learn how the Sturm-Liouville theory is working, so you can develop the solution for the Schrödinger equation. So this fundamental Schrödinger equation, this Schrödinger equation, changed the world revolutionary. It changed everything. Even it changed the logic. It changed even the philosophy. It changed everything. So it's a welcome to the probability theory. When accident is important, just probability theory. So probability theory will be a subject in quantum mechanics. So already I write for you, I think 6 bucks maybe or 7 bucks about what I want to talk about that. So I don't know how much we will be success, because I told you I have not a planned timetable to finish that. So we will continue as much as they will stop us. So we will continue. We will ride in this highway toward the advanced mathematics, and I don't know when we will stop. So as much as I have the motivation, I will continue that. So during these lectures, 3 lectures, I will suggest some problems for you to solve, and you can solve or not. It's up to you. But these problems actually are very difficult, and I want just give you that to push you to, if somebody is interested, push to learn the advanced mathematics, and to do to make a good background for the research if he or she want to continue that. So I was not the student, but it was a student. It was a professor, and in any course he started by the vector analysis. So I think this is the best way, because we will start from the vector analysis now, officially. This is very confusing. It's a very confusing information about the vector. So in elementary mathematics, we think that the vector is the object which started from the point and ended to the other point, and this is we call it V. Huh? But not always that. This is a very elementary things. This is a very elementary things. And the things which you know about the vector, the things which you first, as the first fact, what you need to know about the vector is that the algebra, the algebra of the vectors. Algebra of the vectors will be related to the concept called vector space. Why I say this will be different from what you know? Because by vector I don't mean the real vector. I mean even functions. So for me the function, like for example sinus of this function will be the vector fn. Don't think that how I write it that, just for example that. This is a sequence of the function. If you give me n, I can give you the function. P is just number, x is the coordinate, and a is just you can forget about the a and just write it 1, npx. This set of the function also satisfy the same rules as normal vector satisfy. So for me, a set of the function is the vector. For me, even these matrices are considered as the vector. They are vector, actually. They are matrix, I know. But these three objects can work for me as a vector. Because also these elements satisfy the same rule as a normal vector satisfy. So you need to know that what is the normal vector do. So what's the rule for the normal vector? So functions are working for me as the vector matrix, and also the normal vector. For example, this kind of the vector also are vector, as usual. You know, they are vector also. And they are very easy, very clear, very trivial form of the vectors. They are vectors. You know how our imagination about the vector is different from what you learn in the basic mathematics. We never can call those as a vector, but we will call them as a vector.